Hello, viewers. Good morning, good afternoon, good evening, depending on the time you're seeing this video. My name is Hussein Green, your favorite mathematics tutor. I'm so excited. I'm so happy to have you this moment. Thank you for always watching my video. God bless you. God prosper you and keep you safe. All right, we have a problem here on the board. We are to find the integral of cos squared theta with respect to theta. So how do we integrate this cos squared theta with respect to theta? Now, one of my students in the university gave me this to solve. He said I should help him explain how the lecturer got the answer. This is very, very simple. If you understand some basic rules of trigonometry, there are some standard identities of trigonometry that will help us to integrate this in a very simple and precise method. Okay, now what are some trigonometric identities that will help us? Now let's do this together. Solution. Okay, solution. We have we are to find the integral of cos squared theta with respect to what? Theta. Now, you know we cannot integrate this with this power. So we'll find a trigonometric identity that we can use to substitute this so that this process will be very simple for us. So recall that we have this. Recall that sine squared theta plus cos squared theta equals to 1. This rule is what we are familiar with. This rule is very simple. It has been proven and found to be very correct. So this is true. If I make sine squared theta the subject, I'm gonna have cos squared theta 1 minus cos squared theta. So now this is 1. Now if you have sine A plus B, the answer is sine A cos B plus sine B cos A. All right. Also, if you have cos A plus B, the answer will be cos A cos B minus sine A sine B. Also, if you have tan A plus B, the answer is going to be tan A plus tan B over 1 minus tan A tan B. This is very, very true. These are some basic rules of trigonometry. Now, how will I substitute this so that this power will be cleared, so that we'll have a simple and precise substitute that will make my integration very, very simple. So what I'm going to do here, if you have cos theta plus theta, according to this rule, is going to be equals to cos theta, because we are having theta here and theta here. So here we're having, in this place, we are having theta. Here it was A and B. So if you follow this formula, you are going to have minus sine theta sine what? Theta. That's correct. And if you add this, theta plus theta is cos 2 theta equals to cos squared theta minus what? Sine squared theta. All right. Now, if I substitute, we're having cos 2 theta equals to cos squared theta minus sine squared theta. Now, in this equation now, since we are having cos here, and this is sine, so we can make everything to be cos by carrying out substitution. Now, if you check, sine squared theta is equals to 1 minus cos squared theta. So I can replace this with this. So that is to say that this cos 2 theta will be equals to cos squared theta minus, so this place I will replace it with this. So I'm going to have 1 minus cos squared theta. So that will be, this place of sine squared theta will be 1 minus cos squared theta. So if I simplify further, I'll have cos squared theta, I open bracket with this, minus. So minus times 1 is going to give us minus 1. Minus times minus is going to be plus cos squared what? Theta. Now, if I transfer this to this side, transfer minus 1 to this side, that will be cos 2 theta will be plus 1 equals to cos squared theta plus cos squared theta. And cos 2 theta plus 1 will be equals to, cos squared theta plus cos squared theta will be 2 cos squared theta. So that will be 2 cos squared theta if you add these two together. All right. Now, if I decide to make cos squared theta the subject, I'm going to have, that is, I will divide this by 2, divide this by 2, so that I can make cos squared theta the subject. So this will cancel this. So I will have cos squared, this is over 2. So I will have cos squared theta, this cos squared theta will be equals to this. That will be cos 2 theta plus 1 over 2. Let me write it properly here. Because squared theta will be equals to cos 2 theta plus 1 over what? Over 2. Now, that is very, 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 very correct. Now, we are very close to our answer. Now, you see that cos squared theta is equal to what? Cos 2 theta plus 1 over what? 2. So that means here, the whole of this place can be replaced with this. Remember, this can be written as 1 over 2 into what? Cos 2 theta plus 1. This and this are the same thing. Okay, so I can replace this with this. You see that in this new equation, this expression does not have, the cos here does not have power. So we have been able to clear that power so that our integration process will be very, very simple for us. All right, we're going to have the integral of 1 over 2 bracket cos 2 theta plus 1 with respect to what? Theta. Now, according to the law of integration, you can this 1 over 2 is a constant. Okay, so we have reduced it to this level. We are very, very close to our answer. So what we're going to do here is to integrate them this by part. We'll remove this and integrate. I will also remove 1 and integrate. Of course, if you integrate 1 with respect to theta, the answer is going to be theta. So if we move further to integrate this by parts, this is what we are going to have. We'll remove this and integrate it. By integrate cos 2 theta with respect to theta, that will give us, we'll use substitution to do this integration. So you say let u be equals to 2 theta. And if I differentiate this, this will be du over d theta. I differentiate this with respect to theta. So that will be equals to du over d theta is going to be 2. All right. Now, if I make d theta the subject, let me know this is over 1. So if I find the reciprocal of this, I'll have the theta. I take the reciprocal of both sides. I'll have the theta over du equals to 1 over 2. Now, if I make theta the subject, I mean d theta the subject, that will be d theta will be equals to 1 over 2. You know, this will multiply this du. So d theta is equal to 1 over 2 du. Now, if I now substitute that, that will give me the integral of cos, you know, my 2 theta is now u, cos u dot, and d theta is 1 over 2, 1 over 2 du. So you know this constant will come to the back of the integral. So that will be 1 over 2 the integral of cos u du. Now if I integrate cos u, I'm going to have sine u. That is one of the standard integrals. Okay, so if I have cos u, I will have sine u. The integral of cos u is sine u, so that will be dot sine u. And what is my u? That will be 1 over 2 sine u is what? 2 theta. That's very, very correct. You know, I'm supposed to write plus c, that is my constant, but this is not the final answer. So I'm not going to write my constant here because this is not our final answer. We're going to add our constant when we've gotten the integral of the whole process, the whole expression. So we're going to also integrate 1 with respect to theta. So we've gotten the integral of cos 2 theta with respect to theta. So let us get the integral of 1 with respect to theta. The integral of 1 with respect to theta is going to be theta. So we are going to substitute everything into this to get our final answer. So that will be equals to 1 over 2 is our answer. The integral of cos 2 theta with respect to theta is 1 over 2 sine 2 theta plus the integral of 1 with respect to theta is theta, then plus what? C. So that will, if you expand this, you are going to have 1 over 4 sine 2 theta plus 1 over 2 theta plus what? C. So this is the final answer. So that is to say the integral of cos 2 theta with respect to theta is equals to 1 over 4 sine 2 theta plus 1 over 2 theta plus what? C. This is the final answer. This is our answer. Thank you so much. You see that? That was quite simple. Thank you so much for always watching my video. I am very, very happy. Please do well to comment, like, and share. Also follow me on my YouTube channel. God bless you.